Welcome to Math with Professor V. Here's your latest integral of the day. And I know it looks scary, but it's not as bad as it seems. Okay, and I have put this integral on an exam as an extra credit problem. Only after having solved it for them in class as well. So don't feel like, oh, I blindsided my poor students with this problem. And it was extra credit. But pause the video. If you want a little hinty hint, split up, write the numerator as that first chunk over the denominator, and then separately write the last two terms over the denominator. That's the key to success. Okay, so let's just jump right in. We have integral x minus 2 squared tan inverse of 2x over 4x squared plus 1 times x minus 2 squared minus, and then since I'm taking out a negative, this is going to be 12x cubed plus 3x over the same denominator, 4x squared plus 1, x minus 2 squared dx. Okay, cool. So did you see already x minus 2 cancels here? Oh, I already feel less stressed. So we have integral tan inverse of 2x over 4x squared plus 1, I'm getting good vibes already, dx. I'm just going to split these and tackle them separately, okay? Minus integral. And then for this one, I can factor 3x out of both the terms in the numerator, and then we have 4x squared plus 1. So more canceling fun to be had for us. Look at that. 3x over x minus 2 squared dx. Beautiful. So here's integral 1, here's integral 2. We'll knock them out separately and then put it all together. Sound good? Okay, so for integral number 1, anything popping out at you? Yeah, it's just going to be a u sub. We're going to let u be the numerator, tan inverse of 2x. Now be careful, du, when you take the derivative of tan inverse of some quantity, you have to use the chain rule, and you're going to have 1 over 1 plus that quantity squared times derivative of 2x, which is 2. A lot of people forget that too. Very sad. Let me put some watch out eyeballs so you don't forget it as well, okay? So then that means du is 2 over 1 plus 4x squared dx. That's almost what I have. 1/2 du is, I'm even going to write it as 4x squared plus 1. Not that I need to, but just so it matches perfectly. Perfectly. So there's 1 over 4x squared plus 1 dx. That's 1/2 du. And then tan inverse of 2x is just my u. Oh, love it. Antiderivative, 1/2 u squared. I'm going to put plus c1 because I have another integral to do and I want my grand finale to have plus c. So let me not use it now, you know, that would be wasteful. So 1/4 u squared, how do we write it? We need more parentheses. So tan inverse 2x squared, like that, plus c1, okay? Good, good, good. Love. Now, let's tackle that second one. Where is he? 3x over x minus 2 squared. Okay, 3x over x minus 2 squared dx. Any ideas? No, u sub won't work. That's right, we have to do partial fraction decomposition. So since the denominator is a repeated linear factor, the decomposition is going to have the form a over x minus 2 plus b over x minus 2 squared. Very good. Now multiply everything by the LCD. So x minus 2 squared. And then we're going to have 3x equals a times x minus 2 plus b. How we doing? Okay, you can distribute the a throughout and solve for a and b that way. Let me show you another method to solve for a and b. Let me let x equal 2. I chose 2 because that would make this 0, right? So then on the left-hand side, we'll have 6 equals a times 0 plus b. So bam, now I know b is 6. And then there's nothing to plug in so that, the other term goes to 0. So just pick something else. Pick 0 for x, 1, whatever your little heart desires. My heart was desiring 1. So there we go. 3 times 1, that's 3, equals a times 1 minus 2 plus, I know b is 6 already. If I subtract it over, negative 3 equals negative a. So a is 3. Good. Okay, so let's put that all together. Now we have integral a over x minus 2 plus b over x minus 2 squared dx. So antiderivative is going to be 3 natural log absolute value x minus 2 plus. Now, I don't know if you can do this in your head or you need to rewrite it. It's 6 times x minus 2 to the negative second. So when we take an antiderivative, we add 1 to the exponent, divide by the new exponent. So this is going to be negative 6 x minus 2 to the negative first, or negative 6 over x minus 2, plus c2. Beautiful. So we're pretty much all done. Just remember, this is a somewhat tricky little moment. We had the first integral minus the second integral. So I'm actually going to take this and then subtract these two guys so their signs will change, okay? Oh, let me box this too. We're proud of you. Don't feel bad. How dare I not box the result from integral 2? Okay, so all together now, we've got that 1/4 tan inverse 2x squared minus 3 ln absolute value x minus 2 minus negative 6 over x minus 2. So now it's plus 6 over x minus 2 plus c, where c is c1 minus c2. And I was taught to always keep track of my constants that way. It'll serve you well, especially when you move on to differential equations in higher math, where you just have to be very precise. So let's start with good habits. That way we don't have to unlearn bad ones, right? That concludes your integral of the day. How did you like it? I've done one super similar, but like over a year ago. And I feel like a lot of you are new here. So I thought it would be fun to do it again. It's a wee bit different. And I thought it's a good problem because it actually wasn't that horrible. It just looked really disgusting in the beginning, didn't it? So sometimes just dive in. Don't be scared to play around with problems, even if it doesn't work out. Save that work. Don't throw it away. Learn from it. And practicing that productive struggle helps you learn solution techniques and strategies, and that's invaluable. Okay, so let yourself struggle. Don't default to like look up something online. It's good to develop those pattern recognition skills, reasoning skills, all of that. It's beautiful. So thank you guys for your support. I hope you enjoyed the integral. Let me know if you did anything different. And then don't forget to subscribe, give the video a thumbs up, follow me on Instagram and TikTok, same handle, Math with Professor V. I love you all so much. I'll be back sooner than later. Bye guys.